Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning. Do you wish you could use artificial intelligence to drive your business the way big tech does, but don't have a money printer? Graft is a cloud-native platform that aims to make the AI of the 1% accessible to the 99%. Wields the most advanced techniques for unlocking the value of data, including text, images, video, audio, and graphs. No machine learning skills required, no team to hire, and no infrastructure to build or maintain. For more information on Graft or to schedule a demo, go to themachinelearningpodcast.com/graft, that's Graft, and tell them Tobias sent you.
Your host is Tobias Macey, and today I'm interviewing Jacopo Tagliabue about building reasonable scale ML systems. So Jacopo, can you start by introducing yourself?
Of course. First of all, 9 out of 10 on pronunciation of my name, so very good, very good. Thank you very much for having me here. So I'm Jacopo, Director of AI at Coveo, a public company in Canada, but I actually calling in from New York. I used to be an entrepreneur in Silicon Valley, so I built a company called Tuzo. I was the CTO and co-founder. It was a company that was doing NLP and information retrieval before all of these MLOps tools. So there was a lot of work. We grew it for 3 years and then sold it to Coveo, and then I've been leading like AI and MLOps roadmap at Coveo as well. And I'm pretty active in the open source community and world. So where we basically try to, since we made all the possible mistakes or most of the possible mistakes in DataOps and MLOps, we try to save people some time. And so we're open sourcing a bunch of repositories and data and kind of articles that kind of explain our journey and, like the setup that makes us happy and, the mistake that we made along the way. And I'm also the author of Reckless, which is a relatively popular package for testing ML system, in particular recommender system with behavioral testing. So if you're curious about that, there's a data challenge right now that you can actually participate in for CIKM. So thanks again for having me.
And do you remember how you first got started working in machine learning?
I think it wasn't called machine learning at the time. So I think the first thing that would qualify as machine learning today was a part of speech tagger with Markov models. I think it was 2012, maybe, something like that, 2011, something like that. It's a long time ago. But my interest for a lot of teams that people now associate with ML is older than that. I used to say to VC when we were building a company, I used to do AI before it was cool. As I grew up with this interest with, AI in particular language, formal languages and also natural languages. So NLP was kind of a natural first application. I would say the first modern application in the sense of being Dockerized, deployed and scaled to millions of people would have been at Tuzo when we had a shallow parser based on conditional random fields that would actually help you understand that a query such as blue shoes by Prada is a color and a type of object and a brand and not just a string of letters. And that was used at Tuzo and my company to provide people with a better experience. So that I think would be my first thing at millions of people scale would have been that.
Very cool. So given the fact that you have been working in this space, as you said, since before it was cool, I'm wondering if you can give your take on how you view the current state of the overall ecosystem for ML practitioners, both in terms of the availability of tools and platforms for being able to get work done and the availability of useful resources and tutorials for being able to understand how to do those things.
I think the answer to this question kind of diverge. So the first question is, how about the tooling and things that makes you productive? I mean, it's awesome. It's the best way possible. It's the best moment possible, at least, since I've been born, to be in this field, as you don't have to do much anymore. I think one of the lessons that we learned by building, you don't need a bigger bot repo or other stuff that we open source is how much the field has progressed in the last 5 years. Now, one question that we kept asking ourselves was, what if we have to rebuild what we built for Tuzo today? What technology we keep? And the answer is none. It's 5 years, but the things have changed and improved so rapidly that none of the choices that I made at Tuzo, I would make them today. Not because, not because I'm terribly dumb, but because now there's variety of tools in open source and platform that you can use that will actually avoid a lot of work that I had to do with my first company. My first company basically had a terrible version of DBT that we built ourselves with Airflow and Sparse SQL. Had a terrible version of, Seldon, with our Dockerized deployment, but it was kind of sucked. We basically had a terrible version of everything you have today, but it was terrible and you have to build it yourself. I think now the ecosystem is so mature that for most use cases, not the Facebook of this world and not some niche things when maybe security is super important or latency is super important. But for most use cases, the reasonable scale, as I call it, there are tools in place that gets you from data to serving to monitoring with a fairly small team and with very low barrier to entry. So question number one is, the moment the ecosystem is amazing, I think it's a fantastic moment to be in this field and you can be incredibly productive. Question number two is, how is the educational material out there? And of course, I'm biased. So, like you just admit I'm there. I think there's most of the materials out there is by model. So there's a 1 million word data science article of how you deploy a scikit, logistic regression with Flask. Good. I mean, it's not that it's not useful, but that's really a toy, that's a very small thing that it just runs on an EC2. And there's a lot of materials about what Uber platform does or Meta platform does or what Pinterest is doing and so on. What is really missing or what has been missing, and it's one of the reasons why we're writing so much in the space in the last year, has been something in between the low code or no code or simplified toy environment and the custom ad hoc mega platform for Fang. There's a huge chunk of people in the middle, the reasonable scale, that we think are not as well served by tutorials. As again, everybody will discuss how to serve a petabyte of data or 3 data points on your laptop. But very few people actually tells you what to do with 10 million. Just, it's big enough that you have to worry about, but it's not an unreasonable request. It's not, the population of India, right? You know what I mean? I think there's a huge opportunity, not just for education, but in the market of ideas, also for paper, for research, and, something that we tried to do in the last couple of years of addressing this market, which is super interesting and is where the bulk of application are going to be in the next 5 years.
Yeah, I think that that's a pretty common challenge across all kind of technical endeavors where there's a plethora of information out there for people who just want to go from 0 to 1 of understanding how does this thing even work? How do I do the equivalent of hello world? And then there's a giant gap between that and, okay, this is how you build a system that will serve production grade capacity for Google or Facebook. And everything in the middle is few and far between and variable quality. And it's hard to really get anything that's of kind of intermediate level that gives you enough information beyond what you may already know that doesn't have to start with, okay, here's how you do hello world and then do the next thing. In the process of writing your examples and the repos that you've put together and the tutorials that you've gone through, I'm wondering what your experience has been or the thought process you went through about how to structure those tutorials and how to actually address that kind of intermediate scale and the assumptions that you had to make about what knowledge and understanding they already had by the time they came to your tutorial.
I think for us, which is a process that has pros and cons, but the way to streamline this for us has been imagining myself on the other side as hey, if somebody with maybe my knowledge 2 years ago, not now, but 2 years ago, what would have wanted somebody to explain to me 2 years ago to streamline my process, to somehow speed up my learning in this landscape? And so, it's biased because, of course, talking to a previous version of yourself doesn't exactly generalize much. But as a prompt, you have a very concrete set of skills and person and, type of problems in mind. I think a lot of the things that we build and put out has been successful because we are ourselves a reasonable scale companies. We are ourselves reasonable scale people. We're actually for people that are basically like us and that they have our problems, so to speak. So a lot of things that we put out are the things that I use every day. I don't have to put myself into the shoes of somebody using Metaflow. I actually use Metaflow. I don't have, to put myself into the shoes of somebody using Snowflake. I love Snowflake. It's one of the things that changed my life the most, technically speaking, in the last 4 years. So all of the things that we actually propose are things that we actually use every day, which is how we know that they work at our scale. For our needs, they work. The other thing that I would add is a lot of things we put forward are information retrieval use cases. If you think about where they fit as a functional piece, which has the pros of it's very easy to understand what they do. Even if you never build a recommender system in your life, everybody kind of understand what a recommender system is. You know what I mean? It's something that, you can kind of relate to it as far as input and output goes. And the second thing is that they kind of upper bound the reasonable scale people for data and sophistication. As in e-commerce, even a small e-commerce will generate a lot of data, way more than most people will say in their life. And e-commerce tech is way more advanced than, again, most application reasonable scale. So the argument is, if this runs a transformer-based recommender system with a click from your laptop, chances are it's going to be okay for many other use cases because this is actually on the hardest side of the spectrum.
As you mentioned, the work that you did at your previous company, you said you would just throw away and rebuild from scratch today because of all the changes that have happened. And I'm wondering if you can maybe highlight the most notable aspects of the change that you've seen in that time frame, and maybe even relating that to some of the ways that those changes have been catalyzed or influenced by the accompanying changes that have happened in the data engineering and data management space.
I mean, absolutely. So the biggest change of all, the one that is the most communication, is the most boring. And is when we move our SQL operation from Spark SQL to Snowflake. Again, as I said, like my company was doing information retrieval use cases. So most of our data is semi-structured, like, sort of tabular in nature. There are some fields that are not categorical or numerical. There are some fields that are free text. But if you think of a typical search engine, queries are typically fairly short. So what you actually end up is with mostly tabular data transformation. And for that, Spark, in particular, we're using Spark on EMR, is kind of a pain to work with. Like, it's very slow. When there's an error, you've got these, 100 lines of Scala code that you don't really get, or I don't really get. It kind of forces you to, some patterns that are not super familiar to, to people with my background. And it's very hard to tune properly because there are like a million configurations that you can use for Spark. When you move from that to just do stuff in Snowflake, my life changed completely. Now I don't have to maintain clusters anymore. I can just use SQL, which I'm decent at, to retrieve my data. And I don't have to worry about scaling that or about configuration about the clusters or about any of that. I just throw it to Snowflake and Snowflake figures out myself. I mean, as far as I know from my code, I can be querying SQLite, like a high latency SQLite, because the experience to me is exactly the same. I give you a SQL query and I get back like a data frame, like a list of dictionaries or whatever it is. So that has been massive. We decommission Spark SQL, Athena, and a lot of stuff when you can move to Snowflake, and then unlocks, building on top of the modern data stack, DBT and so on for data preparation, which again, we kind of sort of have that in my previous Intuzo, but it was a hacky, kind of not super good way to do that ourselves. But the principle were there. My point is like, the transition to all these tools was easy for the team because we were already philosophically thinking the same thing. Immutable data, up and only pattern, ELT, like all of that was already in place. It was just with bad tools. So that was a huge time saving and maintenance saving. So that was great. The second piece that I would say in order of importance that will change our workflow was the adoption of Metaflow. So these are more on the MLOps side. So that ops has been, let's say, figured out with, with this new setup, so to speak. And then the question is, well, now the data is aggregated and prepared. What do you do for training your model? And before, if you ever did a model in your life, that it's not like a tidy 4 lines of code, that you send to Keras or to PyTorch. There's like, 100 lines before, 100 lines afterward. There's a lot of checks you need to do, a lot of things you need to move around. And before it was like either a series of scripts that are like, hacky and terrible, or things like, I don't know, Luigi or even Airflow. You can even use the general orchestrator to do that. But that kind of conflates the general problem of orchestrating tasks to the iterative job of the data scientist, and it should be much faster. So enter Metaflow, which is an open source tool that everybody can use. It's from Netflix. So when Metaflow came on board, we kind of throw away all this logic and scripts and kind of clunky pipelines. And now with Metaflow, we have one way of basically doing fast development. So we can iterate locally, and then we can use GPUs when we want from the cloud. But then the same setting can be easily sent to production. So now our feedback loop from, when we try stuff and, want to run experiments, when we have an endpoint running, is much shorter. And also Metaflow gives us a lot of stuff that we didn't have before, like versioning, auto-scaling, and so on and so forth. So this is the second big thing that I would change. Everything else, experiment tracking, monitoring, and so on, is awesome. And now that I use them, I can't live without them. But I would say the two foundational pieces for my productivity and my team productivity has been Snowflake and DataOps and Metaflow for this training loop and fast iteration. I don't know if that makes some sense.
In terms of the mistakes that you mentioned that you had to go through the pain of making and learning from, I'm curious, what are some of the most notable ones that you've held on to and that have influenced the way that you think about building these systems today, especially given the advent of these new tools and platforms to build on top of?
The mistake we made some mistakes because we knew that what we were doing was not optimal. but then building an optimal solution at the time wasn't really possible. Our model deployment packages at the time was like, a Flask app, a Docker app with, when you spin it up, what happens? It goes to S3, you retrieve the latest artifact that is there, and then it's just going to reboot basically the container. It's going to load that in memory, and then it's going to serve a Flask endpoint in Python, right? It was a conditional random field model. So the model was small enough, it could totally fit in memory, and it was fast enough. And we knew that it wasn't particularly good. Why is it not particularly good? Well, it's not particularly good because, every time now we scale it, now you have to scale, you have to download like n copies of the model, which is not, like a super good way of doing this. It's not good because there's no way of versioning or specifying in container which type of model you want, right? Sure, if you always pick the latest one, that may be fine, but sometimes you want to roll back. Sometimes you want to build A/B testing. Sometimes you want to experiment all of that. And if you build just the latest model is what goes in production kind of thing, which is what we did, obviously none of these use cases can be solved. I mean, they can be solved, but with another ACK on top of the original ACK. So our entire model registry and model serving stuff was obviously wrong. It did the job. It was okay. Again, we were most worried about, velocity and kind of iterating that, they're being right, but it was something that we're not super happy with. Plus, last thing is we built it on Fargate, which was good for something, but it's bad because Fargate doesn't support GPUs. By the way, Amazon people, if you listen to me, please add GPU support. So for the conditional random field was fine, but if I have to port the same mentality to what I'm doing today, like mentioned before, transformer model, it won't work, right? So the entire thing wouldn't work. Okay, so that was clearly wrong. And the truth of the matter is that I don't really have today like a full-fledged solution to this problem. So for some of the standard model serving and GPU component, you can use SageMaker or similar tool, whatever you want to use, and it will do a decent job in doing that. At least it will scale for you like stuff properly. It will batch for your request to kind of utilize GPUs a bit better. Some version of SageMaker, I don't think the GPU one also do multi-model endpoints. You can have multiple models in the same endpoint to kind of make it more efficient and cost-effective. But when your deployment thing is a bit more complex, think about model recommendation engine with two-stage processes or something like that. It's still not a solved problem, as in there's still not a tool that I know of. If somebody knows, please reach out, that you can just give and, hey, this is my artifact. Can you please deploy it for me and scale it, and scale it out? So I'm still in search of that type of solution. Of course, now you can build it yourself with a lot of other tools. But my point is like, since I never want to build stuff myself, that is not what I really care about. I'm always looking for a solution that will simplify my life. So that mistake is kind of still partly with us, but at least some of the, let's say, low-hanging fruit has been reaped by this past solution that you can just adopt. I don't know if it makes sense.
One of the things that you just noted in there is the difficulty in being able to say, I have this model, I just want it to be in production. And I'm wondering, what are some of the other points of friction that ML practitioners and ML teams might typically run into if they're trying to go from, I have this idea of something that can be addressed as a machine learning problem, and then to the point of, okay, I have this in production and I'm able to iterate on it and deploy whenever I want to. Just some of the challenges that still exist on that path.
I think a lot of the challenges in that. So if you have, like, let's say the use case, I think is very telling, is there's a new problem. So I'm not maintaining a system, but there's something in my app, I don't know, a churn prediction model, recommender system, whatever, that I want to automate for some reason. I want to build a machine learning out of it. I think today, if you want to build this thing, it's mostly going to be a people and process problem and not a tool problem. And I can say more clearly, like, if you want to solve this problem, you need to strive for one thing only, is velocity. Like, the only thing that matters is the time that it takes for you to build the end-to-end system from when your data lies in your Snowflake to where you have an endpoint that your clients can use and interact with. And then you need to get that feedback back into the same Snowflake so that you can actually join the two data, your prediction and the feedback, and then kind of like iterate on that. I think a lot of people get stuck not because of tooling, but because of internal processing or the temptation of being perfect first, which is really something we should avoid. Being stuck in the middle, stuck for weeks or months into optimizing tiny little things that don't really matter. And how do you know they don't really matter? Well, the actual is that you don't know. Like, until you put something in production, you don't know what is the potential value. You don't know if users interact with it. And you don't even know which are the bottlenecks in your system. Unfortunately, ML is much more of an art than a science. ML in production, well, also ML is a science. But like ML in production especially, It's more of an art than a science. And we figure out a lot of stuff just when we do them, to some extent. Do the least amount of work and sophistication possible to put out a feature that makes some sense. And hopefully work in an environment that reward this. Work in an environment that reward experimentation, safe experimentation, to a check in place and making sure you're not destroying, people's life. But you know what I mean? Make an environment that is okay with the idea that all this thing is going to be an iteration and all this thing is going to be, kind of validated as we go, instead of trying to do something in a cave for 3 months and then try to bring into production by merging 4 teams together and do that. And give the people that build the model the key to production. Like we always stress this end-to-end ML person. The end-to-end ML person doesn't know infrastructure, doesn't know Kubernetes, doesn't know provisioning, he knows how distributed SQL query runs, but he knows SQL to get the data from Snowflake. He knows Metaflow to run stuff at scale in GPUs. Even if he doesn't know how to provision GPU, no worries, Metaflow is going to do it for you. And then he knows enough to send the model to SageMaker and evaluate that. You know what I mean? Like our job as leaders, I think, is to abstract away all the maintenance and kind of like provisioning. But the job of the ML person is not to do the model. The job of the ML person, at least in my team, is to do the entire thing. Because it's only by understanding the entire thing, they're going to know what the problems are.
In that question of saying, okay, as an ML person, you don't necessarily know how to deploy a Kubernetes cluster or how to deploy a pod to Kubernetes or how to manage the scaling, et cetera. And in the tutorials that you wrote, you made a point of trying to focus on a so-called no-ops approach to being able to get models out into production. And I'm wondering what you see as the benefits of being able to empower the ML engineer to be able to actually own the whole end-to-end workflow of saying, I have this model, now it's in production, and not having to involve an operations team. And what are the points where you might decide that you do need to bring in an infrastructure team and some of the challenges that a typical production engineering team might need to be aware of as they start to move into the space of ML ops?
It's a very good point, and I think there's no clear-cut distinction. But I think for most people, like in a company, my point is that in a company, these two things can totally coexist. There are new features that are still experimental. You're still testing on 5% of your user, of your clients. And then they may go in a totally no-ops approach because, again, you're optimizing for speed. You're optimizing for velocity. And the faster the person that builds the model can deploy, get feedback, and iterate on that, the better it's going to be for the company. That's why if you start the end over and kind of, finger pointing or like, rewriting stuff at that level, you're going to kill innovation. And you might be doing a lot of work that doesn't really matter at the end, right? If the person runs this for a couple of weeks and it doesn't really work, we just wasted one person time. If now we spend 2 months to bring this prototype in production and nobody really works, now we spend 2 months of time on different teams, right? There's an analogy to the reinforcement learning thing, right? There's a moment for exploration and there's a moment for exploitation. So in exploration, you privilege speed and self-serving. The people that build the feature should be autonomous. In the exploitation, so when we figure out that this recommender system is going to make us $10 more million at the end of the year, you may want to optimize for, margins, latency, robustness, and so on. So that's the moment when another team can get involved. And again, in healthy companies, this is not an or, this is an end. Like there are some things that work in one way and then you somehow move them the other way. It's not that there's just one way of doing stuff. And hopefully, at least that's what worked for us. What people should be aware of when moving from normal engineers to models, well, the things that everybody says, right? The model fails silently. I think that's the most common problems of ML, right? Because when you have an endpoint that is a normal API, when typically fails, it's gonna go into 500 or like something, and there's been a Datadog or alert or something, and it's like, oh, there's something wrong. And not all of bugs, but a significant amount of bugs are gonna be catched because the endpoint somehow fails. In models, the vast majority of bugs are not because the endpoint somehow returns an error or just dies, and because the model is doing something that you really don't want him to do for whatever reason. Again, we can discuss the causes. And so I think that's the difference between the two things, is that you should be paying attention to a wider variety of failure as compared to a normal deterministic system. I think that's the biggest change for ML production systems.
In terms of the level of infrastructure knowledge that you would expect an ML engineer to be aware of, I'm wondering, At what point would you say, okay, stop wasting your time on that, just go and use this managed service instead, or stop wasting your time on that, bring in the production engineering team? Like, what do you see as the kind of useful overlap between an ML engineer understanding infrastructure and then the infrastructure engineer needing to understand some of those vagaries of ML systems?
I think the ML engineer needs to know enough in his company to be independent and get feedback from his model. Then how much enough is enough? It really depends on the maturity of the company. Like even in the case when there's a data engineering team, like called ML platform in our case, but the same thing. I don't think the role of the ML platform team is to take over or somehow rewrite what the ML people do. Is to build tooling and abstraction so that the ML people can still do their job in a less fast or automated fashion, but still in abstracting away all the details. I don't think communication between teams is maximized when people need to talk to each other. The communication between teams is maximized when we have an API, a contract, or abstraction that actually works. So to me, the job of an ML platform team is not to talk to ML people. Sure, let's talk, but is to build tools that makes my ML people, as productive as possible. Depends on when you tilt the balance, right? You may have an incredibly good ML platform team that simplifies everything, so the requirement for the ML engineer is very low. Or you may have as less mature companies when the ML platform is nascent, and so the ML engineer needs to kind of know a bit more of the details. But in theory, in an ideal world, I think the job of development engineer ends with once you validate in production, ends with the artifacts and what you need to kind of deploy, and then everything else is being taken care by the platform. So,
as ML engineers and ML teams are going down this path of saying, okay, I have this ML problem, I've built a model, now I need to figure out what this end-to-end life cycle will look like and how we manage to build in these feedback loops and the cyclical aspects of this. As you said, there's a whole suite of tools out there, open source, managed platforms, et cetera. I'm wondering, what are the kind of key elements that you see as being useful to put into a rubric to figure out what are the tools that we need to use? What is the selection process for understanding which ones will fit well in our environment and suit the expertise that we have on staff, and just some of the kind of challenge of this paradox of choice that has arisen in the space?
There's surely vendor tools fatigue in the space. I also experience it myself, right? Even if I think we are in a relatively stable place, as in we kind of figured out most of the things we wanted to figure out, so we're not exactly drowning in pain points. I still occasionally, of course, look at the new cool kids on the block, or I've been asked to to chime in on a new product feature or something like that. So that's definitely true for everybody at different level of maturity. My usual suggestion is start simple and start for the things you cannot do without. The thing we cannot do without are three. So one is data. So where is your data and how you retrieve it? If you're doing, again, tabular or semi-structured data, I think the problem is being solved by the BigQuery, the Snowflake of this world. So there's not much thinking there, I think. Then how do you do your training? And the question is going to be, which type of model do you train? You train a massive deep learning model, you train logistic regression, how much data are you realistically facing, and so on and so forth. So find a tool for the training that actually suits your need. Training means training, so actually doing the training, and the ancillary things of how do you version the model you get from training? How do you reschedule training every day? Or how you retry a training if it's failing. Okay, so all of this needs to be figured out. And then, of course, deployment. And, because if your model stays on your laptop, it has no impact in the world, right? So you need to find a way for the model to be served. Attention, it doesn't really mean that online serving is the only way. For example, recommendation, a very common, and I would say prevalent way of serving them, even at Netflix scale, is in batch. So if you know your user, for example, you can pre-compute movies recommendation for your users every day. And when the user log in, you're not going to run a prediction. You're just going to get the same information from a cache. The last open source stuff we did with NVIDIA is actually following this pattern. Okay, so you pre-compute all your stuff and then you put them in DynamoDB, and then you can serve them even with a Lambda and so on and so forth. So these are the key things that cannot mess. Otherwise, you don't have a machine learning pipeline. If you don't have data, if you don't training into the model, you're doing something else. And so I would suggest starting with this. And once you get comfortable with this, you can go into the higher level of how do I track my experiment properly? How do I monitor my system in production? Because again, monitoring it may be tricky and so on. But start with the basics and then, go on the higher level stuff.
Another aspect of the challenge of doing that tool selection is what you were saying earlier about the fact that the space is evolving so rapidly. And I'm curious what you have found to be some of the useful interfaces for being able to say, okay, this is a seam where I can easily take out this tool and replace it with something else if I find something better, or if this tool stops being maintained, or if my requirements change, and just how to think about the interfaces and the sockets where you can plug in the different pieces and without having to rebuild everything from the ground up every time.
This is a concern that most people have, and I think it's a very genuine one. In our case, in our setup, this boils down to the choice of the backbone of the system in how you build your ML pipeline, which in our case, as we mentioned, is Metaflow. I think similar reflection would apply to more traditional system like Airflow Prefect if you don't want to do an ML specific orchestrator, for example. But if you think about what I said, like 3 functional pieces that I mentioned before, the connection between them is already fairly clean. Like my connection to a data warehouse is a SQL query. If Snowflake ceases to exist tomorrow, which is, by the way, fairly unlikely, but I can just replace it with BigQuery, and most of my code is going to basically stay the same. Actually, my downstream code is going to stay exactly the same as soon as I replace the client to talk to BigQuery instead of Snowflake. My training doesn't really depend on anything. It's pure Python on PyTorch or TensorFlow, whatever. Again, they're here to stay. They're not going to change. And the result is an artifact in S3 that gets shipped to whatever deployment platform that I picked. So the way in which the 3 parts talk to each other, data with training is SQL, training with deployment is, a versioned artifact. And those, at least to me, are already solved, that they're not going to change, they're here to stay. And I have to say that most of the other tools that I saw in monitoring space or experiment tracking and stuff like that are also very good in this integration game. As in, they provide you very, very nice hooks to kind of improve what you have very easily. And of course, if you get tired of them, you can also remove them or change them, I would say, with not much more work. Like for us, like changing Snowflake would be, just going back on Snowflake to Spark SQL would be like going back 5 years in our life, and erasing Metaflow would going back like 2 years or something like that. Once that is in place, I think every other tool has been, like relatively straightforward to incorporate into this vision.
On this question of the kind of reasonable scale moniker that we've been addressing, as we said, it's the question of going from your laptop to actually serving production traffic with potentially thousands or hundreds of thousands or millions of users. What are some of the common bottlenecks that you tend to run into along that path from training to production? And then once it's in production, some of the performance issues that you might need to account for. And I'm also curious how the specific application of ML might influence the manifestation of those bottlenecks. So whether it's an NLP system or a recommendation engine or a computer vision problem, things like that.
For some problems, NLP is a good example. Let's take if you build something in like contemporary NLP with deep learning and vectors and so on, at some point, it's very, very likely that your prediction system is going to have a retrieval phase in which you're going to be asked to go and find a vector that is similar to the vector that the user is inputting for some sense. This also applies to recommendation as well, right? If you have a recommender system at some point and the user is viewing a Samsung TV on Amazon, you may want to go to a place and fetch similar Samsung TV, to then recommend it to the user, right? So the first thing you need to do is fetch similar ones, and the second thing you have to rank them, because of course different users may have different price point or preferences and so on. That part for us in the last year, I think, has been the part where we're actually working the most in production. The retrieval of vector search basically at scale. Okay, it's a very hard problem. Now there's a bunch of startups solving in Pinecone, for example. There's open source stuff that you can use like Vespa. Like there's a bunch of stuff that of course you can use. I think Redis right now is also a built-in memory vector search and something like that. And of course some model like TensorFlow Recommender include like a KNN inside of them if you deploy them as a Keras model. So, but that is a huge difference between what happens in your laptop and what happens in production. What happens in your laptop when you don't really care that much about the latency of that moment. You just care about the quality of the recall. But when you put it in production, now you have maybe 1 million users. Now, the vector search over hundreds of thousands of items need to be very fast. And that's why, like complex use cases with more latency, like for example, information retrieval, become especially challenging. Because that's not the end of the game. Like, once you retrieve that, you still have to do stuff to produce value. So there's a bunch of things that need to happen. and they need to happen in a very constrained amount of time. While when you train your model, or even when you may start it trying out with a bunch of users, like a bit of like testing, is less important. You can sacrifice some of that to be fast, to have an accurate prediction. But then when you actually deploy it, you need to be fast and scalable. And so at Coveo, there's been a lot of work into making our index processes and so on dense vector compatible. It's a very challenging, honestly, it's a very, very challenging work. It also comes into question, what is the best possible architecture for this? Do you have two indexes, one dense and one sparse? Do you have one that kind of does both of this? Like Elastic, for example, it's a popular open source choice that sort of does both. But there's an argument to be made that maybe the vector search in Elastic is not the most optimized one for machine learning. So now what do? We have a part of the company that use Elastic and a part of the company use something else. It's a very tricky thing when you actually have to work it out. But it's been an interesting journey so far.
To that point of there being some particularly challenging problems that you've had to tackle as you move to these reasonable scale levels, what are some of the machine learning applications or specific use cases or model architectures where it's not really feasible to run at so-called reasonable scale? And those are still kind of the domain of the big tech companies that have deep pockets to be able to spend on the research and the infrastructure and the talent to be able to realize these capabilities.
I think the main division is going to be mostly the first parameter that is going to put you out of the reasonable scale. It's going to just be a boring one, which is how much data do you have. At some point, even nice tools like Snowflake and so on become just prohibitively expensive if you really need to run all the computation we run on Snowflake, like on that. And then it will make sense to have internal tools that are built, on more old scale but better scalable platform that you can control in tuning, because at a petabyte scale, tuning your Spark cluster is actually a value. And my scale is annoying, but a petabyte scale is actually makes the difference, between a successful company and not. So I think data is the first big hurdle. Remember what Peter Norvig said when they asked, like a long time ago, why Google was so good? And he was like, we don't have better algorithms. We just have more data than you. Because the single reason why models in production actually work better is because this company has way more data and can harvest way more data than you could ever do. And then, of course, their scale makes also the second part interesting, which is the modeling aspect, right? A 1% increase in modeling accuracy for a recommender system at petabyte scale is going to produce $1 billion, down the line. So everybody wants to optimize for it. If you run at reasonable scale, a 1% increase in a recommender system, may or may not be actually change the ROI of the company or of the client. So it may or may not be, maybe even justify the amount of GPUs you're spending in proportion. You know what I mean? So there's a lot of trade-off that makes sense only after a certain level of scale. But if you read what I'm always interested, if you read Pinterest has been doing that a while. If you read some of the things that Pinterest is doing, it's not the whole story, but some of the things they do is really basic, like the dot product between users and pins or something like when you read about that, it's not sophisticated. It's actually way less sophisticated than a lot of things that other people do. But they are so good at producing good representation of user and products into vectors that at the end of the day, they can kind of simplify the problem. Well, we have a lot of data. We're very good at this representation. Let's do a dot product. It's a very easy thing to do. You know what I mean? I also think there's something that people don't say that much, which is at a large enough scale, simpler things becomes convenient again because data makes up for the difference in performance.
To your point of saying, if I have a recommendation engine, I'm able to improve the accuracy or the recall by 1%, it's not going to have a meaningful impact on my business. What are some of the kind of premature optimizations that people might fall into where you can say, don't bother wasting your time with that. It's not going to have the impact you think it's going to do. Focus on making sure that you can catch errors faster, or focus on making sure that you can reduce the latency from model development to model deployment. What are the things that make sense to focus on at reasonable scale? And what are the things that are just going to be a waste of your time?
So first thing, second thing, and third thing is going to be your data cycle. So make sure that your data is collected properly. Make sure you have the proper, ELT patterns and things that actually makes you confident that what you do is replayable, it's scalable, it's version, and you can kind of count on it. And second, make sure that the data you ingest at the end of the pipeline are joinable with the data that you start with, right? If data is not joinable, data doesn't exist. It's a general thing. If you cannot put data in relationship with other data, just not having that data. And you'll be surprised by how many times I saw people deploying a model in production and thinking later of like, well, what do we know if we're going to be successful or not? Like, well, that's the first question to ask before building the system, not the last one. At the moment when you write the first line of code, you need to have very, very clear how you're going to get the feedback from the user back into the system. If you don't have that clear, don't bother building the system in the first place. So data is always the first place to start looking for, like optimization, which means if you don't have much data, you can do data augmentation or synthetic data generation. So like knowing your data, become one with your data is important for everybody. That goes for Tesla. There's a famous paper by Carpazzi about that. Become one with the data set. And it's even more important at our scale. The second thing that I would say, try to build a model that's simple enough to produce value, but not complex enough that you don't immediately understand, when it's wrong. The secret to many applications is understanding that distribution is a power law. So in many things, like, customer service, for example, let's say you need to build a model that tells you if a customer is happy or sad about a topic, okay? And you don't have any data and you don't know how to start. A very, very easy thing to start is like highlighting from your backlog of data, like sentences that are very clearly expressing like anger, like I hate you, I want to deactivate the account, whatever. And you literally can regex your way out of your first month. And then you put the prediction in live and then you collect the data at that point to kind of bootstrap your machine learning system. Like the first rule of machine learning is always asking if you need machine learning. And in many cases, the truth is that you need it, but maybe not at day one. Or you also need it day one, but you don't have the data. And again, data is the most important thing. So to get to the point where you have the data, you need to do some tricks here and there to do that. So these are the things that should occupy your first month of a new ML feature. Not latency, not scaling, not GPUs, and so on and so forth. And then, the more you get confident, the more you can improve that. Of course, that doesn't apply to everybody. Like, depending on your level of experience and maturity, you could, when I need to build a recommender system nowadays, I don't start with root. I already have a baseline when I know what things work and not because of my background. And everybody has his own, depending on their application. But if it's a new problem, don't be afraid of being simple and dumb. Like everybody needs to start somewhere.
In your experience of working in this space and putting together these tutorials and talking to people who you encounter in conferences and in your day-to-day work, what are some of the most interesting or innovative or unexpected ways that you have seen people design their ML systems and be able to build out and prove the utility and value of their ML approaches to a particular problem?
There's a bunch of cool things that I've seen recently. I wouldn't say it's a finished job, but like my friend Ethan has published a blog post recently on using Materialize and SQL to somehow do ML monitoring, basically a pure SQL solution to ML monitoring, which I think is an interesting and clever take on the problem. I'm not sure if it is right though. So Ethan's idea is that you don't really need Python or fancy stuff to do the bulk of your monitoring. What you need is a good streaming service, let's say Materialize, and some SQL queries to kind of like, do basic counts, okay? And I think it just like publish like an open source post on that. And I thought it was a clever, it's all the things that I find that try to simplify things. It was welcoming from my perspective. I'm still not sure if it's completely right. I'm not sure if you can actually do proper monitoring without at least some statistical testing or, some fancier stuff, especially if you do NLP, if you do more complex stuff than just counting or tabular problems. But I thought it was a very clever spin on the usual, well, you need a full monitoring tool solution. And it was like, well, maybe, but also maybe something that literally is like an open source simpler. So that definitely like resonated with me. And I thought it was pretty cool. Generally speaking, I really like all the serverless stuff. So I really like server, not as in this case, I don't mean the framework specifically or the AWS implementation, but the general idea where the world is mutating, where the world is kind of moving, when you don't really care about much, if not just, giving a function to some provider and the provider is going to run it. So every time that I see people that are able to serverless their way out of their pipeline, I'm always kind of like thinking, well, good job. Like, I really like the approach. So, yeah.
In your own experience of working in this space and building out your own systems design and managing these machine learning problems, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
The most interesting fact that I realized that, which is controversial, But like smaller team in this space may or will typically outperform bigger team if they have the proper tooling and data in place. Like small team will drastically outperform teams that are like 10 times or 20% bigger if they know how to leverage this ecosystem in a way that makes their feedback loop very, very short. And if they have a way to abstract away the non-important stuff, or sorry, not the non-important, the not differentiating stuff like infrastructure scaling and so on and so forth. So one thing that I learned is that it's very hard to judge the productivity of an ML team by size. As incredible teams can actually be produced by relatively small company. I mean, I know it's not small by most definition, but if you think about OpenAI, it's like 300 people or something like that. Well, if you consider consider how complex is what they do, you would have guessed from the outside there would be a much bigger company. That's my point. So I think that's one interesting learning that I have is like smaller talented team will actually perform bigger ones because it will cut on dependencies and all the communication channels, which slows everybody down basically. That's surely one interesting learning. And on the other side is, well, what building models is super cool and I really like it, but it matters less in practice than what I thought it would do. It's not true in every use cases. It's not true in every company. It's not true when life or death is on the table or when marginal gains means billions of dollars. But in many cases, I think I came to the realization, and many ML people came to the realization in the last 4 or 5 years, which is that our job is not that important. I mean, it's cool and it's fun, but where the value is how that job is connected in a principal way upstream with our data, as we said, or downstream with our user. That's, I think, where the really applied ML person shines. The applied ML person shines in using the right tool for the job, but mostly understanding how his job is in a context where the model doesn't have just to predict, but needs to predict certain type of thing to certain type of people in a certain way based on certain data. And that, I think, where the value is. But on this, I think is less controversial. I think more and more people, especially that have these two sets of skill, like research skills and practice, they do both things. I think more and more of us realize the huge gap between these two words. They're both interesting and worthwhile in their own right. But then I think a successful person needs to be able to switch off the hat or the research hat when you do one or the other. And on the other side, you need to switch off the too practical hat when you're trying to advance the field. But these two things don't necessarily go hand in hand. And I'm not sure if it's good or bad or where we're going. But I think that many people in my position deeply realize this every day now.
As you continue to build and manage your own systems and work in the ML space, what are some of the things that you're keeping a close eye on as far as evolving patterns or upcoming tools or practices and some of the new capabilities that you think are worth paying attention to or useful resources for people who want to gain more understanding of this space and evolve in their own capabilities?
So I'm generally interested in team topologies. In large organization and people work with data together. The fact that you are at ML end-to-end data engineers, it doesn't mean you're the only person touching data. So at some point, there's going to be some data what you need to share with the analytics engineer or the BI folks or something like that. And I'm always interested in talking to people that are solving this problem, as I think it's a totally non-solved problem, like the collaboration of people with different skills and different downstream needs over the same data warehouse. I think is one of the big themes of our time. Now that all the data is centralized and we pretty much use the same tools or languages, but how can we work together instead of stepping on each other's toes? So this is one tip. If anybody has interesting thing to say, please reach out to me. I think this is a pretty novel but exciting area of research, and I hope to devote a bit more of my time as well in solving this. On existing things, so less far out in the future, there's a lot of emphasis right now in streaming infrastructure. So in going from batch to quasi real time, I would keep an eye on that, not because it's going to happen in the next year or so, or even 2 years. I don't think that's going to happen for most people close enough. But I think that's where the future naturally lies, and it's always, the saying, right? It's like skate where the puck is going to be, not where the puck is. So it's always good to keep yourself, a bit ahead of the curve. But yes, I think streaming is super cool. I just think that the amount of people that right now can operationalize it and make sense of it are a tiny minority because the tooling is so hard to use. But in a couple of years, I see that as a growing, even considering the investment, the Databricks and Snowflake are making that. I see streaming as obviously a growing market for ML ops and, ML applications.
Are there any other aspects of this question of being able to design and build ML systems at reasonable scale and your experiences working in that space that we didn't discuss yet that you'd like to cover before we close out the show?
No, the last thing that I've mentioned is testing, just because we've been working a bit in this and the open source stuff as well. So testing a model is hard, and it's much harder than what people think. Not even monitor, not even when the model is online, but even when you have a test set and you test your recommender system or classification and you get a number out of it. And based on that number, you decide if the model is good enough to be shipped outside. There is a tremendously hard thing to do. And we ourselves came to realize this relatively recently, which is why we built Reckless. We couldn't find anything that will satisfy our needs. So, we didn't set out to build it. It just, there was nothing that could actually satisfy our needs. So we built this package and open source it. But there's a lot of nuances in what models do in real life that are not captured by test set or what we call point-wise metrics. Like the typical example we make is, recommender system. Since a lot of people watch blockbuster movies, if you build a recommender system that is slightly better at recommending Batman, it's going to give you the impression that it's a better recommender system if you measure by hit rate or MRR or whatever. But then if you zoom in, it may be that by being a bit better in Batman is actually destroying the viewing experience of every Italian viewer because they're a niche, but now the recommender system doesn't really take care of them. And so the point is not telling you which one is the best recommender system, but it just kind of make everybody aware that deciding what to put in production, what the model is going to do when unleashed, is harder than one measure on held out data points. So if you like this topic, super happy to talk about that. Again, we're organizing a free open competition with nice prize and some students awards as we speak. If you're passionate about building recommender system and evaluating them according to not just accuracy, but fairness and robustness, please get in touch.
Yeah, and I'll make sure to add a link in the show notes for people who want to get involved in that. All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as my final question, I'd like to get your perspective and what you see as being the biggest barrier to adoption for machine learning today.
I always do three. First, algorithms are hard, but this is getting better because models are getting better abstracted away and so on and so forth. Second, MLOps is hard, but of course, it's actually getting better because of all the tools and the things we discussed. And third one is interesting question in the space are typically geared or set as an agenda by people that have problems that nobody else has. And I think that's still hard, as in the people that actually do interesting research at reasonable scale are very few because of the constraints. So we need to be better at this. But yeah, those are the three big barriers for me. But the message is, this is a fantastic moment to live, because 3 years ago, my answer would be, these three barriers are unsurmountable. Nobody can do that. Now, 2 out of 3, can be tackled with, by reasonable scale people that know what they're doing. And hopefully in 2 years, they will be able to be tackled by almost anybody, right? If we continue in this trend. So it's a very, very good moment to be in this space.
All right. Well, thank you very much for taking the time today to join me and share your experiences of building and designing machine learning systems and how to think about the set of requirements that map well to the types of scale that most people are going to be encountering. So I appreciate all the time and energy that you've put into that, and I hope you enjoy the rest of your day.
Of course. Thanks so much for having me. And guys, thanks so much for listening. Ciao.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.